All right, we're live. Hello, everybody. Welcome again. We're doing part 2 of our VR and AR workshop. And today we're going to have a look at some of Godot's AR functionality. So today's stream is again sponsored by Merguldo. Just to read out everything aloud, this talk is supported by the Faculty of Informatics at the University of the Basque Country and its Masters in Computational Engineering and Intelligent Systems. The event is organized by the faculty's 3D Extended Reality Lab, Merguldo. So, with that out of the way, I saw some wonderful pictures online yesterday from yesterday's session from all the students watching. And yeah, that was really cool. Very nice to see. So welcome to all the students once again. And I hope that we will be informative again today, having a talk about AR. Slide-wise, we are going to keep it a little bit simple. I'm hoping to give a bit of an overview here, but most of it we will be looking at through actual code and building. So when we are looking at AR, AR is in a bit of a strange position in that it's still relatively new. So what we are seeing is a lot of different solutions to the same problems over the different ecosystems that exist. Phone-based AR is the most well known at this point in time. So where you are using your phone's camera and it shows the camera image on the phone, and you add some augmented things to that. So think of something like Pokemon Go is probably an example that everybody knows. That is supported by two frameworks, AR Core on Android phones and AR Kit on Apple phones. And while we have plugins for both, we don't have a really big community working on those. So they are lagging behind the implementations that are there. But it is something that, if that is interesting to you, is something that we that you can look at and see how that works. Just a reminder, I see some chat messages come in. I am not going to be answering chat again during this session. We'll have a Q&A at the end of the presentation. Anyway, sorry, I got distracted by that for a second. So, yeah, so we do have plugins for those. You can try them out, but because there isn't a whole lot of community behind them, they lag behind the implementations a little bit. Also, it is very clear industry-wise that the industry is really focusing on AR through headsets or AR through glasses. That's really where the future lies. The phone-based AR is sort of, there's still people doing really interesting and cool stuff with it, but it's kind of disappeared in the background. So be aware of that. So Godot itself, we really focus on OpenXR, kind of, what we were already talking about yesterday with our VR support. So we really chose to make OpenXR the base on top of which we build everything. And therefore, most of the support that you have out of the box all focuses on what OpenXR delivers. Now, in OpenXR and also WebXR, which we also support in the core, there is standard support for pass-through. So when you look at glasses, well, these are not AR glasses. I wish they were. They're normal glasses, but let's say that you have AR glasses. Obviously, you see the real world around you. All that needs to be done is present the virtual elements on a screen or on a reflected screen in your glasses headset. But when you are using something like a Quest, obviously you can't see anything. You can only see what the displays have. So the Quest has got cameras on the front that are used for tracking, but that are also used to capture the environment around us and allow us to display that camera image on inside of the headset, so that for the person, they're just seeing the real world around them, and whatever virtual content we render is presented on top of the real world. So that part of the functionality is available both in WebXR and OpenXR. There are some little gotchas because there are some small platform differences, but for the most part, we try to implement that in a way that you need to do very little customization from one device to another. And if you build something that uses pass-through in Godot, it's generally portable between the devices with very little extra work. So, but pass-through just gives you, the same experience as with glasses, that you can see the real world. You have some virtual content on top of that, but you want to do more. You want to be able to interact with the real world. You want to know where things are in the real world, or you want to make sure that virtual objects that you place in the real world end up being in their previous place whenever you restart your application. So those sort of features, that sort of functionality, is something that we have access to through various APIs, but is also functionality that is still very much in development. So Meta, and this is one of the reasons why I'm using the Quest today for our presentation, in the OpenXR ecosystem, Meta is furthest ahead with that. They have a whole bunch of features that we can show off. But it is important to realize that those APIs, and they're called the Meta Scene Discovery APIs, they are only available on the Quest. They are not available on other devices. Now, Pico and Android XR have similar APIs as well, so that they can offer similar functionality, but both are still very much in development, and they're all being superseded by this wonderful thing called the OpenXR Spatial Entities API. So that is where the OpenXR working group has come together and has looked at all these different implementations and sort of said, okay, what is the common denominator here? How can we create a API that will service all these devices? And offer that in a way that is portable between the devices. Now, unfortunately, that is very, very new. The Spatial Entities API only became public, if I remember correctly, at the start of last year, maybe a little longer ago, but it's about a year ago. And as a result, the APIs that are currently available only support a few features, and a number of newer features are still under discussion to see what we can add to the OpenXR API. As far as implementations go, the only public implementation of spatial entities right now, everything that is available in public, is on the Android XR ecosystem. So right now, to demo spatial entities would be a bit on the early side. So this is one of the reasons why I'm going to show off Scene Discovery today, to show how these sort of systems work, and yeah, hopefully give everybody an idea of where we're going with this and where we will end up, hopefully. All right. So the last thing that is really interesting. Oh, actually, there's two more things that I wanted to mention about this. The other one is obviously the Apple Vision Pro. Apple is fairly far ahead with a lot of this functionality through the existing logic that they made for our ARKit. So for the iPhone, they now obviously have the Vision Pro, where a lot of that functionality is coming forward as well. However, Apple has chosen not to embrace OpenXR. They have created their own API ecosystem. So there lies a interesting problem, that if you want to create something that runs on a Quest and runs on an Apple Vision Pro, you have to deal with both different APIs, both different ecosystems. Godot today does not fully run on Vision Pro yet. There is work being done on that. I can't promise anything there. I can't commit to anything there. It's work that Apple is actually doing in conjunction with us. But yeah, it's open source software. It needs to go through the right processes. And even then, today, everything that is public, that is that you can look at and explore with, goes as far as immersive VR. It doesn't actually contain any of the AR features yet. So it's likely coming, but I can't promise. I can't promise how soon that will be available. So for anybody who wants to experiment with this sort of thing, or even build things with this, I highly recommend sticking or remaining in the OpenXR ecosystem. And right now, Quest really is the best device, in my opinion, to do most of these things. And I think that will change really quickly because Google is catching up really quick. Pico is catching up really quick. So I think by, end of this year, start of next year, we'll probably be in a position that suddenly there are other devices that really have this feature set down. But today, right now, Quest is an absolute winner. Okay, so the last thing that I wanted to talk about is a very controversial topic when it comes to AR, and that is the access to the cameras itself. So for the longest time, when you were using a Quest or similar device, because all the vendors have followed suit, Apple included, they didn't want developers to have direct access to the cameras for privacy reasons. Now that is now no longer the case. However, it is incredibly protected. So you need to ask your user for permission to get access to the camera image, and you have limits to what you can actually get access to. The other thing that you have to keep in mind when looking at functionality like that is you are running on the device itself. It is, relatively speaking, not a very powerful device. Compare that to a PC. Obviously, a PC has much more power. So if you want to grab the camera image and you want to do your own AR features there, you want to throw some computer vision logic against it to try and detect things, you're going to be fighting in resources with the features that are offered by the headset itself. And that has been a real big problem because some of the features that a lot of people want who are dealing with AR aren't available yet. A good example, for instance, is marker tracking. That is now becoming available. That is actually one of the first APIs that is part of spatial entities. But market tracking is still very limited, and unfortunately something that I do not think we have support for Quest yet. Might have been introduced really recently, but I haven't played with it if it has. But it's a very powerful feature. I have played around with market tracking with spatial entities. And you can do some really funky things. For anybody who's sort of wondering, like, what is he talking about? What is marker tracking? Marker tracking is where you have a QR code or a Eureka code, so like a small printed out square pattern of squares, black and white squares, that the headset can detect. Now, everybody is aware of QR codes, right? You scan your QR code with your phone, and your phone finds out what that QR code is and brings you to a website. In an AR situation, it goes beyond that because it now knows the location of that QR code. It knows the orientation of that QR code, and you can therefore use that QR code and the location of it as an anchor point for virtual contact. So, for instance, an experiment that I was working on a little while ago is where you put a QR code on the table, like a playing card with a QR code on it. You put it on the table, and suddenly the character that belongs to that playing card appears in your headset. So that is the sort of thing that we can do with marker tracking. But again, very important there is that is functionality that is only just coming out as far as APIs are concerned on the headset. If you want to do it yourself, which some people have implemented by grabbing the camera image and throwing your own logic against it, you do have to be aware that you have limited resources, and you might find yourself in a situation where it's not performant or not fast. Might still be a lot of fun to experiment with and learn with. Godot itself does have the ability to access the camera image. There is a standard camera API in Godot. All you need to do is go through that permission system and tell the Quest, like, I want you to ask the user for permission to use this, and then you can access that camera as a texture, and then you can use all sorts of inbuilt features like compute shaders and things like that to analyze that image and do something with it. It is unfortunately an area that only very few people have actually been experimenting with, so there is very limited information available if you want to go down that track and if you want to play around with something like that. So for today, we are going to focus on on the Quest itself and the APIs available on the Quest. And we'll see how far we can get with everything. But I'm hoping that I can get through pass-through. I want to talk about hand tracking today. How do you do hand tracking as opposed to controller tracking, what we did yesterday, and then obviously having a look at the scene discovery API. So that's the plan for today. That brings us to the building an AR application using Godot. Now, before we go to Godot, something that I kind of missed out on yesterday is to point everybody to our documentation that we have online. So at docs.godotengine.org, you will find all the documentation about Godot. There's some really nice getting started articles here with some nice beginner samples that you can run through. But if you go all the way to manual and then to the bottom, there is a section here for XR, and we have a whole bunch of tutorials here for XR. A number of things in here are things that we've discussed yesterday. But for today, there are a few important things in here that I wanted to point out simply because it would just take me too long to explain them in detail here. So I just wanted to point everybody to this, that they need to be aware of, okay, these are things that you need to do. Now, the first thing is actually looking at the second option here, the deploying to Android tells you everything that you need as prerequisites in order to actually publish to or push to the device. It's unfortunately not as simple as what we did yesterday, where you just download Godot and press play. In order to run something on an Android or on a phone, well, this is an Apple phone, although kind of the same thing applies here. Let's say that you had an Android phone and you want to run something on that, or if you want to run something on a Quest, which is in its heart an Android device. I'll probably get slammed by some people like it's Horizon, but you know, it has a big overlap with Android. It has Android as its core, so so you need some more steps for those devices. Basically, you need to make sure that you have OpenJDK installed. You need a Java environment for compiling and building the deployables. And we specifically need OpenJDK 17 installed. The other thing that you need is install Android Studio. Now, there is an exporting for Android here that specifically looks at phones, and that shows you that there is a command line version of that you don't have to install the whole environment. But I find it easier to just install Android Studio. You've got it all up there, and all bits that we need to use are then in place. And then the last thing is you need to do a little bit of configuration in Godot to make sure that Godot knows where the Android SDK is, so that it can communicate with that. We'll show the windows that you need to know about in a minute when we're in Godot. But this is a really good page to just go through and kind of get, you know, an overview of everything that we will be talking about. And then the export to for Android page is a good one, just to get some more detail if you want to know some more behind the scenes information. And this also gives you some more detailed step-by-step install instructions if you need it. Unfortunately, I also can't run through that today because I already have all this stuff installed on my laptop. Now, the other thing that you need to do in order to deploy things to the device, and that goes for Pico, that goes for Android XR, for the Galaxy XR device, all Android-based devices, is that you need to enable developer mode on the device. Now, the way to do that differs from one device to another. For a Quest, you need to open up the Meta companion app for the Quest on your phone. Hopefully at the setup you've linked that up with your headset, and there should be an option there to switch the Quest into developer mode, and that gets you that allows you to deploy things to the headset. The other thing is, as you'll see, I have always got my headset connected with a USB cable. It needs to be a proper high bandwidth data cable, or else it won't work. Once you've got it set up for the first time, it is possible to run your connection with the Quest over Wi-Fi, but I've personally had the experience that using the cable is just more stable and better, and especially for today, where I'm going to be showing what I'm actually seeing in the headset, and I'm just streaming everything that's happening on the headset back to my PC, I've also found that the cable is just more stable and more performant. So um, it all depends on your own experience and your own preference. But yeah, I highly recommend using the cable. The other prerequisite, or this is a nice to have, but I recommend everybody who uses a Quest for this sort of thing to install, is the MetaQuest Developer Hub. You will see that I have got my MetaQuest connected here. Ignore all the things at the top. The things at the bottom here are important. This panel allows you to do a number of things. One thing that I have done is this option here on the right called proximity sensor. There is a little sensor between the eyes right over here. I hope you guys can see that. That detects whether I'm wearing the headset. And whenever I take the headset off, it detects that I've taken the headset off, and it will turn off the headset. And if I leave the headset off long enough, it will actually turn the headset to sleep, or it'll first turn the displays off, and then later on it will turn the headset to sleep, which is really annoying when you're doing development work. So in a situation like this, where I'm streaming, where I'm showing people, and I'm periodically wearing the headset to show things off and then going back to doing things in Godot, I like to turn that proximity sensor off. A lot of other people will put just a little sticky note on the sensor. That's another way to do it, but I really like that Meta has given that as an option here. Just as an aside, here you can find the ADB over Wi-Fi option. If you turn that on, that would allow you to use the headset in wireless mode, everything that we're doing right now. But again, I've personally found that it just works more stable over the cable when you're doing this type of work. But there are obviously scenarios where you would want to use ADB over Wi-Fi and push things out to the headset over Wi-Fi, especially when you're in a situation where you're demoing things to someone, or you're working together with someone who might be wearing the headset in the room and you want to communicate with the room. Now, the other thing that we're going to be using in a minute, I'm not going to start it until we're a little further along, is that I actually have the ability to control recording videos on the device and to cast what the device is seeing to here. So obviously that is the feature that we're going to be using in a minute, so that you guys can see what I'm seeing in the headset. So a brilliant piece of software that I recommend anybody who uses a Quest for development installs and uses. It really has saved my hide a number of times. So cool. Let's go and have a look at Godot itself. Now, again, just like yesterday, I have already set up a project so that I could install a bunch of things and just save time. But we will run through those and how you would normally install those. For you guys, obviously, when you start with something new, you again go to the Create Project over here. And that works the same as yesterday. So you give it a folder, you give it a name. We're again using the compatibility renderer for now, but as I said yesterday, for especially once 4.7 is out, I would highly recommend using the mobile renderer instead. But for now, we are sticking with the compatibility renderer. Okay. There we go. All right. So this is mostly an empty project. I've only installed a few things in here, and I set this up basically the same as our VR game from yesterday, but we're not going to be using extra tools today. You can use bits of extra tools in your AR application, especially the pickup and grab logic is something that you would probably want to get out of there. But I wanted to show today just what it looks like if you start from a scratch environment. Also with an AR situation, because you are loading into an environment that you are using together with the real world, you aren't going to do things like the loading and the calibration stuff and everything that we talked about yesterday, because that doesn't make sense. You cannot move the character virtually through a virtual world while you can visually see that you're standing still in your room. So you would use very different techniques there. Now, the first thing that is very important is that we go to editor settings over here, and we are going down here to Android. Where are you hiding? export Android. So this is what the what that page, the documentation page that we just showed, was talking about. We need to tell it where our OpenJDK is installed. We need to tell it where our Android SDK is installed. This exact path that you need to copy will actually be visible in Android Studio when you open up Android Studio. And you need to set a debug key store. Again, on that page that I showed are the instructions for creating this debug key store. It's just a command line command that you need to execute. And it's basically just an encryption key that it uses to send things to the headset, and the headset knows what the who basically created it. Obviously, if you want to actually put an application on the store, you would use a release key store that is a lot more secure. The other things we can pretty much leave as default, but yeah, not much more there really to say about those things. It is the settings at the top, these 4 things, they are really important that they are set correctly. We have some OpenXR settings here, but I do not think those are important today. But yeah, just to let you know that there are some editor settings there. The other thing that we need to do is we need to go down here to manage export templates. And again, I have already run through this because this is a step that takes a few minutes to run through. But as I said yesterday, the download of Godot was really small. We have this 80 megabyte zip file with the editor in it. You expand it, you end up with 120 megabytes or something like that executable, and that is Godot. But if you want to release your game, whether that is on Windows, whether that is on Linux, whether that is on an XR headset, etc., you want to export your game with a nice packaged version that doesn't have all the editor and debug functionality inside of it. And for that to be possible, we need to install what are called templates. So this nice little UI lets us do that. It shows me that I've got a bunch of them installed for previous versions of Godot. If the current version of Godot's templates are not installed, it will show this message in red and say, I don't have it. And obviously you just have then the download and install button to basically just install these things. So you press that, take a few minutes to download, and it will put those in place. That file is slightly larger. I believe that's a gigabyte download from the top of my head, but it's because there is an executable or a set of executables in there for each and every project. For Android and Apple, there is actually a whole build system that gets installed because of the requirements of these devices. So we need this in order to deploy to a headset. Cool. Now, the other thing that we really want is go to the asset library and search for vendor. And we find the OpenXR vendors plugin. And confusing enough, you will find multiple. Now, this is something that luckily is about to be solved in 4.7 releases because we are moving from our old asset library to the new asset store, and the asset store has versioning information stored with these libraries so that it knows which version it needs to pick for the version of Godot that you're using. Obviously, for us, we are picking the latest one, version 5, but you might need to go to, say, version 4 if, for whatever reason, you need to work on, say, Godot 4.5, because the minimum version for version 5 is Godot 4.6. Now, I know that the versions are a little bit confusing because they line up so nicely with the Godot versions, but it is important to know that the vendor plugin has its own life cycle and its own versioning, and it's pure coincidence that version 4 happens to coincide with Godot 4. So it is version 5 of the plugin that I have installed and that we will be using today. Alrighty, so that is one of the things that we have up and running, and I'm going to talk a little bit more about the vendors plugin in a minute. But I first want to also mention I've got a few assets, just a few images and objects that we'll be using. I've put a shader in here that we'll be using in a minute. But the other thing that's really important that we'll be using is this file called startxr.gd. Excuse me, getting a bit of a dry throat there. Now, just to explain that, excuse me, there is a help page called a Better XR Start script. That startxr file is the result of this. So if you would copy all the code fragments here together into a file, you would get that startxr script. I'm not going to go through the whole thing. It's completely explained over here, but it is basically the same as that startxr component that we used in XR Tools, where it does all the setup for us. But I don't have anything else. So other than that, this is a very clean setup. So just like yesterday, the first thing that we need to go to is to project settings to make sure that that is set up correctly. And one thing that I did want to point out is we don't see the vendor plugin in the plugins tab. When we installed XR Tools yesterday, XR Tools did show up here and we actually needed to enable it. The vendors plugin is different because it's a GD extension based plugin. It does that automatically. So don't be afraid when you don't see that. That's also very important to note because on a few places on the help pages, it will tell you to enable it here because older versions of the vendor plugin did need to be enabled, but the latest versions, they're all GD extension based, which is Godot's C++ extension system. We no longer need to do that. So that is working. I'll also show something really cool that we added to the vendor plugin that we are not using today, but I do want you guys to know about it, but I'll show that when we're done with this a little bit. This time I'm just using Jolt Physics, so we're not changing that. But I have already set some of the OpenXR settings. So I've already enabled that. I've already done the foveated rendering settings, but there is more that we want to do here today. And the first thing that we want to talk about today is the reference space. Now remember in my presentation yesterday, I was talking about the problem in VR where our tracking system has a center point in the room in our tracking spot, and we are seeing where the headset is in relation to that. So it is very possible that our player might be moving quite far away from there or already is far away from that point. And therefore, when you start a level or you start an environment, you suddenly find yourself in the wrong spot. So we have that whole calibration step that we have. Now, in the MR situation, we are in the real world. We don't want to move where the player is. The player needs to be, or the person who uses the application needs to be where they really are in the real space. So we want a little bit different control over what we consider the center of our play space to be. Now, with the default stage reference space, that center point, I don't know how many of you have already used a VR headset, but when you first set up your VR headset, you actually need to draw out a area in your room that you consider safe to play in. That's called our boundary space. And in stage, our center is in the middle of that boundary space. Now, there is some different interpretations between different vendors of what the default orientation is and whether you can change that orientation. So there are some small differences there. For a quest, if you use stage, that spot stays in the middle of your boundary stage and it doesn't change, whatever you do. Even if you use the recenter button on your controller, nothing changes. For MR, we want to use this option called local space. Now, before I go that, just really quickly, local is a situation where the center point is actually where your head is. So when you start your game or when you just reset, your origin point will be where your headset is. And then obviously once you start moving your headset around, you will move it around that center point. It's a really great setting if you want to do a simulator. So you want to do a racing game or a flight sim or something like that. But for our purposes today, we want to do local floor. And local floor means that our center point at the start or at the moment that we recenter is going to be straight underneath the player on the floor. So at that point in time, our XR origin 3D point that maps the center point in our play space to our virtual space is going to be right underneath where the player is standing. I can then walk away from that. So that doesn't stay the place where the player is. I can easily walk a meter forward or go to the left or anything else, and I will no longer be standing at that center spot, but that center spot will be there. If I do my recenter, so again for Quest, that is holding down that button for a couple of seconds, it will automatically recenter. Wherever you are in your room, it will now move the origin point, the center of our play space, to where the player is, and all of a sudden that is the center of our world again. So that is important to know. Now, as I said, when your application starts, you're there. But I'm using air quotes because you can't trust that. That's not part of the specification, and different vendors react differently. Meta has gone down a situation where they detect when you put the headset on and it recenters at that point in time. Although I'm not quite sure how official that is, because that is something that I just have experienced, but not consistently. However, generally speaking, when you recenter your headset, that is the space or the point that it will remember until you recenter again. And then, like I said, sometimes when you move into a completely different space and you put your headset back on, it sort of goes like, okay, I need to recenter again. So be aware of that. In local floor, the assumption can be made that the XR origin point is where the player is, but it's not a given. So you might still want to do something there. Generally, what you would do is when you move too far away from that center point, is just show a message on screen at some point to inform the user, hey, you might want to press the recenter button, and you will be recentered again. And again, it depends a bit on what your application is, right? If you're only showing things that are anchored to the real world, it doesn't matter anymore where the center is. The whole scene discovery and anchor system will actually automatically update itself whenever the player recenters where they are. So that all works. But if, for instance, you want to have a UI, a screen that is, where the player is standing, then obviously when the player walks away from that, like for instance the default interface that is in Quest, if you walk away from that, that's now just hovering in the middle of your room. You press that recenter, you want that UI to appear again. And the nice thing here is if you link that UI to your XR origin node, the XR origin node automatically becomes the center of our play space again, and that screen, that UI will be in the correct place again. So a whole bunch of information all at once, but that is the difference between the stage and local floor reference space, and why we're using the local floor reference space today, because we really want that center logic to just work. The next one is environmental blend mode, and this tells us whether we want to blend in the environment, the real world. And by default, it is set to opaque, which basically turns that functionality off. So basically, when it's opaque, it means that our expectation is that what we render virtually is all that the player sees. Now, in a pass-through or a glasses mode, we don't want that. So there's two other options here. The first one is additive, and that is really targeted to glasses format, because you are always seeing the real world. Even if you are showing virtual content, it is always semi-transparent. What you see virtually is always added on top of the real world. So that is why they call it additive. The other mode is alpha, which is what pass-through allows, where you actually are using a real transparency layer on your on what you're rendering. And only where your virtual information is transparent, you will now see the camera background. So you can really obscure things in the virtual or in the real world with virtual content. So additive and alpha are kind of dictated by the hardware. And as a result, Godot does have automatic fallback logic that if, for instance, you choose alpha because you want to use pass-through, if you're on a glasses format that doesn't support alpha, that only supports additive, it will automatically switch to additive when you start. Unfortunately, some of the headsets require certain things to be started up, and you can't start up in pass-through mode right away. That part, by the way, is getting better, so I might be working on a slightly outdated information here, but we'll see that in a minute. In theory, changing this to alpha should automatically enable pass-through mode. However, we are still going to add the logic in a minute to turn pass-through on and off. In doing so, we'll add the code that if your headset can't start in pass-through mode, you still have the option to enable pass-through anyway. Excuse me. My nose is giving me problems these last couple of days. That's annoying. So those two settings are now set. We will scroll down a little bit because there are more settings that we want to use today. And as I said, we will be using hand tracking today. And hand tracking, the thing that is really important, controller tracking, if you have controllers, is always available in OpenXR. But hand tracking is an additional system that needs to be, first of all, checked whether it's even supported by the headset. Not all headsets support hand tracking. But if it is supported, it also needs to be enabled. So we simply click that tick box to tell Godot, like, we want to use the hand tracking API. However, there are two more options here that we do need to tick as well. And that is, what type of sources do we accept hand tracking data for? And these are named a little bit weird, especially the first one is named a little bit weird. But hand tracking unobstructed data source basically means we are using the cameras on our headset to visually see our hands and recognize where our hands are and what our finger positions are. So not quite sure what the where the name came from, but that is the name that OpenXR gave it. But we need to enable that if we want to, actually track our hand. And obviously, the logic for tracking the hands itself is all handled by the headset. We just interact with the OpenXR API, but we need to enable that. The other option is controller data source. This is an option that few headsets support. I believe Quest supports it, and Steam VR supports it. There might be others, but those are the only two that I know for sure. And what this means is when I'm using controller tracking, I can now use the hand tracking API to know how my hand is holding the controller. So I'm getting skeleton data and positioning data for how my hand is positioned on top of the controller, which is really nice in a VR game where you want to show the controllers the player is holding, and you want to accurately show the hands on those controllers. I'm going to enable that right now just for fun so that we can see, because it will also allow us to automatically switch between pure hand tracking and controller tracking with hand tracking information. And you will see that when we hold the controller, the hand will behave slightly differently. We're also going to enable this option called Hand Interaction Profile. Now, we didn't really talk about this yesterday, even though we've been using it. But when you have a controller, all the actions that you perform on the controller are handled by what is called the action map. And we will look at that in a minute, but you'll find it down below at the bottom of the screen. And that provides us with, which buttons the user presses, whether the grip button is pressed, whether the joystick is moved. So all that logic that we're using through extra tools all goes through the controller through the action map. Now, the action map is set up in what they call interaction profiles. They are profiles for every type of controller that map how those controllers work with your application. We have a default action map in the system that covers almost all use cases, so most of the time you don't even have to worry about this, but it can pay off for more complex games or applications to build your own action map, and at that point that becomes a little bit more important. Now, when I have hands and I am using hand tracking, I don't have buttons or anything that I can press. And to be exact, the whole hand tracking system is completely separate from the controller and the action map system. If I want to create an application where I can seamlessly switch between controller tracking and hand tracking, I might want to be able to react to certain inputs through the action map. And that is where the hand interaction profile comes in. So the hand interaction profile allows us to recognize a couple of gestures. It recognizes a point gesture, it recognizes a pinch gesture, and it recognizes a grab gesture. And it will map those gestures to action map input. So for instance, for the grab on the controller, I can press the button that we used yesterday in Extra Tools to grab objects. I can now recognize the same input by making a fist. That would then trigger the grab action, and I can use the same logic that I was using with my controller. I can now use that same logic with my hand. So that is a nice thing that we will be looking at in a minute to use. Now, it will tell us that it wants to restart, but we're not going to do that until we're finished. I'm going to skip over the spatial entities settings because we are using scene discovery today. But if you want to do everything with spatial entities, same thing, you will need to enable these things for the logic to actually work. By default, it's disabled. If people don't use it, we don't want to enable it because it all takes resources. Eye gaze interaction is another really interesting addition if you have a device that supports eye tracking. So that is like the Quest Pro and the Galaxy XR. Name the devices that have eye tracking. Steam Frame obviously will have eye tracking. The eye gaze interaction again adds an interaction option to the action map that will be controlled by your eyes. And this one only supports positional information. So it creates almost like a virtual controller that is positioned right between your eyes and is oriented in the way that you are looking. It's fun, but it's limited. But it's fun to play around with. So that is the only core functionality in OpenXR around eye tracking. There are other APIs on the way if you want to do more with eye tracking or if you want to know where each individual eye is looking. But the same problem as we were talking about with pass-through is a problem here as well, because unfortunately, knowing where a person is looking can be a very dangerous thing. It depends obviously a little bit on how much you trust the developer of the application that you're using. But even if you trust the developer, especially in a environment where other people are involved, let's say that you have a multiplayer game or or an application that multiple people are wearing headsets and interacting with each other, if you are communicating that sort of information or making the player's character react to where they are looking, you could do some nasty things. A really good example, for instance, which you now have on Apple, where a lot of things are controlled by eye tracking. If someone is using eye tracking to type in their PIN code to get access to a system feature, if someone can see how your eyes are moving, they could guess what your PIN code is. So things to be aware of. There are dangers in these APIs, and the industry is moving very carefully with these things because they do not want to be put into a place where someone does something nefarious with the data and all of a sudden that blows up in our face. So be aware of that. But by default, we have the eye gaze interaction, and on a headset that supports eye tracking, that is a really cool feature to play around with. I'm not going to talk about these things, but it's worth looking at. But what we are going to talk about is this next session, meta, because one of the things that is really interesting is that you see that even though we've enabled pass-through through our environment blend mode, we also have a pass-through option here. Now, the pass-through option here actually enables a whole bunch of extra features on the Meta headset. So we're going to enable that to communicate to it like, yep, we want to issue the permission check for pass-through, and we potentially want to have access to the additional pass-through APIs. You'll see that there's a whole bunch of other things here that are really cool. So we can deal with face tracking, body tracking, all things that we don't have time for today. But features that are interesting to play around with and do things with. There's 3 things around hand tracking that we can add additional functionality to with our Quest headset. The aim tracking is an additional set of functions that allows you to recognize additional gestures. We're not going to be using that today. The hand tracking mesh I am going to enable because that saves us some time. This allows us to retrieve a mesh for the player's hands that we can now animate. And the hand or the mesh in this case is the correct size for the player's hand. So instead of having to supply our own mesh, which would be the other option, and the option that will be cross-platform, but has some other things to be aware of, we can just grab it from the API. And I really hope that an API like this becomes a shared or a multi-vendor OpenXR API at some point, because if you do lock yourself into the Quest if you use something like this. The hand tracking capsules is a nice API that allows you to get a number of collision capsules for the hand so that you can do some interaction. That one I'm not going to enable. Again, same kind of thing. It's fun to play around with, fun to use, but there are options for doing that ourselves. And this is again where, for instance, extra tools comes into play. We do have a lot of that logic already in extra tools that we showcased yesterday, where we could push the cubes around and things like that. So it is possible without using this. Simultaneous hands and controllers. I am going to enable that just for fun. This is really a function that I believe should just be on by default, but Meta made it an optional thing for backwards compatibility issues. In older times, you were either using controller tracking or you were using hand tracking. And you could switch between them, but you could not have your right hand tracked by a controller and your left hand tracked normally. Now, Quest can do that today. It's not a problem for Quest anymore, but for backwards compatibility, they don't enable that feature unless you tick that tick box. Now, we're not going to look at the Anchor API today, but we are going to look at the Scene API. So this is our Scene Discovery API. So we're going to enable that, and we will work with those. All right. I want to really go fast through these other options because we won't be using them right now, but just so that you know what they are aware of. Composition layer settings, they are on by we skipped the color space. Color space is on by default. That is something that also in my eyes should just always be on, but we had to make it optional for backwards compatibility purposes. But it allows us to know the color space in which we are rendering stuff and showing stuff. And it just means that the colors are correct in displaying, because there are some differences between some of the headsets. Composition layers, we might, if we have enough time, talk about composition layers a little bit later. But composition layers are a nice way to present UIs or 2D UIs within a 3D environment. And Meta has a whole bunch of additional settings that you can use that are not part of the default spec. So turn that on. Dynamic resolution is a beautiful feature that Quest added not that long ago, where it allows the headset to dynamically change the resolution at which we're rendering depending on how busy the Quest is. So this is a way to keep the frame rate up by changing the resolution at which we render. Yeah, it's a nice feature. It's on by default for that reason. Headset ID just gives an ID of the headset. Again, I think this is also linked to being logged into a Meta account. but it provides a headset ID for the headset that is unique to the headset. So in a situation that you are in a multi-user environment with multiple people wearing the headset, that allows you to identify the people in that space. The same with co-location discovery. I believe that those two do work together, but co-location discovery works together with our scene API and allows us to access the system where a room can be shared among multiple people. So you can scan the room with one quest, and then you can invite other users with other quests that are in the same physical space as you, and you share the room scan, and all those people can work together in an AR environment. Really, really cool. If you have multiple headsets available to play around with, highly recommend playing around with that, because you can make some really cool cooperative experiences that way. Application Space Warp is a really cool feature that allows us to render at lower frame rates and have the headset interject calculated frames in between. A nice feature to hit frame rates if you have a really demanding application. Again, not something that we are going to look at today, but something that is handy to know. And the last one is important for what we're doing, but I don't think we'll get to actually use this. But environment depth allows us to not just scan our environment, but get access to the depth sensor on our headset, so that we can occlude things that we render. So I have a monitor in front of me. If I render something virtually that is behind the monitor right now, I would see that through the monitor. If I use the environment depth API, I can make it so that it knows that that monitor is there because a depth sensor detects it, and it will therefore hide whatever is behind the monitor that I'm rendering virtually. But I don't think we're going to go and get enough time to look into that today. Other than that, scene API, there's one setting here, and that's the collision shape thickness. And we'll see this in a moment when we are actually playing with scene discovery. Scene discovery will allow us to detect where our walls are and where our floor is and our ceiling is and all that sort of thing. We can add collision shapes to those, so that, let's say that I throw a ball, it bounces off the wall. However, for physics to work, we require that shape to have a thickness, and by default, the information that we are getting from the scene discovery API is a plane that has no thickness. So we are setting a thickness here. 0.1 means a 10 centimeter thickness. That sounds like a lot, but for physics, you do need something chunky in order to make sure that we don't accidentally go through it. So that was in a nutshell, really rocketing through all the settings here that are important or available in Meta, and which ones we are using today and have therefore all set on. Now, there are additional settings here that you find for other headsets. So let's say that you want to work with Android XR and do things there. You will find the settings here that we need to do. And there's a bunch of more things, but that's too much to go into right now. Now, obviously for shaders, already enabled that one. And I'm not going to go into hybrid app today because that's a really cool feature, but that is also very new. But it basically means that you can mix different forms, so you can switch between a 2D application and an immersive application and things like that. But that goes way beyond our topic for today. All right, so for some of these settings that we changed, we do need to restart. That's an unfortunate thing that we need to do. So let's first get started with actually making something work. We've talked for almost an hour and we haven't built anything yet. So in this case, I'm not using extra tools because I also wanted to take the opportunity today to show how quickly you can get up and running, building something completely from scratch. Especially because when you are doing an AR/MR application, you're right now, there aren't really good frameworks out there yet to help you along. You really need to start doing things that way. So we're going to start with a new scene. As always, I'm going to call that main. That's just my personal preference. You can name it whatever you like. I'm going to save that as our main scene, and I need to have a few things. Now, even though we're going to make an AR application, I still want to default with our environment. We are going to adjust our environment later on. but we are going to place that in by default now because we do need these little bits. Light right now, we are obviously not going to have the lighting coming from where our actual lighting in our real world is coming from. There is an API in the works that will allow the headset to determine where the light is coming from based on what the camera sees and give you an estimate and allow you to update the lighting accordingly. And there's some really cool features on the way around that, including that you would even be able to create, let's say, a sphere with a mirror surface, and you would actually see the real world reflected in that sphere. That's something that is coming. So be aware of that. World environment, yes, we don't want the world right now, but we still want that in default, especially because we want to be able to turn on and off the pass-through mode. So we need to have something that we can see. But also, we want to be able to change the environment to a different background when we are turning pass-through on. Then, for every XR application, you have to have an XR Origin 3D node. That is the bare minimum that every XR application needs. Well, actually, the bare minimum is an XR Origin and an XR camera node. Those are the two that we must have. Like we've already explained yesterday, the Origin node denotes where the center of your play space is in your virtual space. So we track all locations from everything in relation to that node. And then obviously the camera is where our headset is in our world. Now, what I do like to do, even though the positioning of the camera is completely controlled by the system, I do like to give that a default value just so that we can see, like, yeah, the player is usually that far off the ground. Now I'm actually sitting, so I will actually be lower, but it gives us just a visual indication. All right. So with those two, the last thing that we need is we need to add our start XR script. That did not get a class name. So what I'm going to do is I am going to create a node. That is the most basic building block that Godot has. And now when you look at that, let's actually go and rename that to start XR. You can simply drag that script from our file browser into the editor slot here on the right, and that turns this node into our start XR node. Now, the beautiful thing from our start XR node is that it's going to do all the work for us to get OpenXR up and running and get everything initialized, and yeah, get everything to a point where things work. The only setting on here that is available that is also important is the maximum refresh rate. So headsets like the Quest can run at different headset refresh rates. I believe with the Quest 3 you can run on 72 FPS, 90 FPS, and 120 FPS. Not 100% sure if there's a 144 FPS version. Basically, with this setting, we are locking it to 90 FPS. That's just the default that we've set on this script. There's, if depending on the application that you're making, you might want to set this up all the way to 120 or 144 even. It will query the headset and ask the headset what refresh rates are available, and then it will choose the highest that is closest to the number that we specified here. All right. So in theory, this should give us a working game or a working application that can run on our headset, but that doesn't show us anything other than, hey, I can look around. Now, if I would press this play button, and I'm not going to do that right now, but we've shown it yesterday, that would run this game in PC VR mode. And obviously I can use something like Steam Link or Quest Link to stream that to my headset and see the game. But if I actually want to run it natively on the headset, I need to do a build and I need to publish that build to the headset. And luckily, that is incredibly easy to do. For that, we need to one time go here to project and export, and we need to set up an export preset for Android. Because again, like I said, it is basically an Android device. I'm going to rename that to Quest because we would generally set up multiple of these if we have different headsets that we test on. And now we need to do a few settings. So it already tells us a few things that we need to change. The first one is I need to enable this in my import settings. Well, we're actually going to do that once we're finished in this dialog. Or can it? Oh, that can open at the same time. Oh, very nice. It says, do you want to import things there? Yes, I do. And that needs to have a full save and restart. Let's do that a little bit later. Let's finish setting this up first. The first setting that's really important is this setting called Use Gradle Build. Godot has the ability to export to an Android device directly with a pre-made APK in which your game or application is injected. But for XR, we need to run more complex logic that is not possible that way. So we need to run a full build. And we do that by taking that on. And it immediately starts saying that, hey, our Android build templates are not installed. Well, we downloaded the templates, but we haven't added them to our project yet. So that is another step that we need to do in a minute. Most of these settings can all be left to default, so don't worry about any of those. There is... Oh, it doesn't show the warning right now, but there is a warning around this unique name because when we leave these empty, there is a possibility that the name that is constructed from your project settings leads to something that it doesn't like. But we don't really need to care about that right now when we're testing. That becomes important when we are actually sending this out to someone. The thing that is important is down here where we have this section called XR features. And right now it's set to regular. That means that XR is not enabled. We need to change that to OpenXR. We need to tell the export system that we are creating an OpenXR application. The other thing that we need to do, and this is only required for certain standalone headsets, especially if we want to use the vendor plugin, the vendor extensions in OpenXR, we need to enable the correct plugin. So we are going to a Meta Quest, so we need to tick that Meta plugin tick box, and that will add those things there. Francisco, I'm going to leave all questions to the end of the presentation, so I will try and get back to you at the end about that. Other than that, we need to scroll all the way down because we don't care about most of this, although there is one here that I do want to point out, if I can quickly find it. These are all the different Android permissions that we could potentially opt into. And obviously, if you do want to, here it is, if you do want to have access to the camera data, the raw camera data, you want to have that camera texture, you have to turn on this setting for camera to make sure that, that we ask for permission for that one. We are not doing that today. We are just using the pass-through system, and that will already ask for the required permissions, so we don't have to worry about that. So keep scrolling, it's a long list. And here we now find a number of settings specific to individual hardware. So we got some settings for Android here, and we have some settings for Meta. So hand tracking, here we can actually detail it out whether our hand tracking is optional or required. Do we allow our game to work with controllers, or do we force that our game has to work with hands? So I'm going to leave that at optional so that we can switch between controller and hand. But if you purely want hand tracking, you can put that on required. There's also a hand tracking frequency. You can turn that on high if you want to have slightly more precise positioning of the hands. I'm just going to leave that at the default low, but okay, we want to see that. Pass-through, same deal. Do we want to be able to switch pass-through on and off? Or do we want to run our application and force pass-through? Now, if you're making an AR application, you probably want to put that onto required. Right now, because I want to show being able to turn that on and off, I am going to leave that on optional. I'm going to leave the other options alone. There are some experimental features that you can opt into. There's an overlay keyboard that you can use for data entry and stuff like that. All not really relevant for what we're doing today. The last thing that you can see here is that we can mark which devices we can run on. That's mostly used by the Meta Store to limit certain things, and that's specifically because the Quest 1 doesn't support the newer OpenXR features, and you can't have an application that can run both on Quest 1 and on Quest 3. You need to make separate exports for those. And of course, there's some options for Pico. So, long story short, we have now done all the things here that that we needed to do settings-wise, so we can close that. That is set up. Unfortunately, I do need to do a reload current project for that ATC setting that we did. So let's just restart. Hopefully that's the last time that we need to do a restart for things. But now we still need to get rid of that error that we had. And that is what we do by going to project, going down here and selecting this install Android build templates option. And this will tell you like, hey, I'm going to create this Android build folder. I'm going to put some stuff in there. And that is stuff that we need in order to push out to the Quest. Boom, that's there. We can see our Android folder there. We're in good shape. Now, the last thing that I want to do before we run this for the first time is go here to debug. And I want to make sure that this setting, deploy with remote debug, is on. Looks like that we enabled that by default now, which is really good. This simply means that the application that we install here is going to communicate back to our editor. And it means that we're therefore going to see some output in our logs, and we can do some easier debugging. It's also a prerequisite if we actually want to step through code in our debugger. All right, with all that set up and done, let's go and enable this. All right. Here we go. Now, I do apologize. My desk is quite messy, but you can now see what my headset is seeing. Now, in order to run something on here, so we've already been talking about that is how we run in PCVR mode, but we want to run it on the Quest, and we do that with this button over here, and we select the Oculus Quest option. Same situation as yesterday. We have a new project, so it wants us to know which scene do we want to run. Well, we only have one, our main scene, so we say select. Oh, sorry, I could just do the other option. Select current, and then it will build it. Now, the first time that this runs, it takes a couple of seconds, so bear with me while it runs through this. And it will take a few seconds every time you have restarted Godot. But once this has run and it's running in the background, it will actually run much faster every time that we deploy. So we can already see some log output here. That means that our application is running. And I can now go over here, and we can now suddenly see that it's already asking me a few things. So I'm going to go and grab my controller. There we go. And it says here, allow this app to access spatial data. Yes, I do. Allow. And that was the only thing that it luckily asked us for. So that was what I was talking about around the permissions that I wanted to ask for, to make sure that that we can actually use that functionality. So it's going to ask the user one time before it actually gets there. Okay. So let's quit that application again. There we go. Put it back on my messy desk. And that is how simple we can actually run an application on the device. So if we would have done that yesterday with our application that we created yesterday, it would have been a matter of install all the prerequisites. So Android Studio, OpenJDK. Once you've got that, you can use that forever. You would have to install the template, so that Android folder, and you would have to set up that export template. And the moment all that is in place, you can just run it on the device through here. All right. So now that we have a working application, let's start making it do something. And the first thing that I want to do is I actually want to start doing my hand tracking bit. Now it works a little bit better, a little bit different than how we did it with our controller tracker. Now remember that we got those as a bonus from extra tools. So we need to now do a little bit ourselves, but we need to start with an XR Node 3D. And we can say that's for our left hand. And we are going to set our tracker for that. It has a long list here, not to the left hand, but to the hand tracker left. So this is for our controller tracking, and this is for our hand tracking. So we're going to select that one. And that now means that this node will be placed wherever my left hand is. And it will be basically where the center of my hand is. And then again, the exact position of that differs a bit from platform to platform, but it usually starts at the palm. Let's also create a node like this, but now for our right hand. And now we select our hand tracker right. The pose we can leave on default. There are no poses involved here. So we do that. Oh, and I also want to use this show when tracked. Let's turn that on so that we don't see something if we don't have anything. And now we're going to add our first meta-specific bit of functionality. And we do that with our add child node, and we go and look for OpenXR FB, excuse me, and we want our FB hand tracking mesh. So, and now I just need to remember, I think we actually need to put that under a skeleton node. No, it is actually a skeleton node. Oh, that's interesting. So I guess we don't need to set up. Yeah, that's interesting. Okay, that's cool. That would then work just right away. And oh, the thing that I also forgot is I also like to give this a default position that makes sort of sense. Just so that we have one on the left and this one 0.51 on the right. So let's add another FB hand mesh, but now to our right hand. And I believe that that should be enough to actually have them. Now we do require a material. I'm just going to add a standard material for now, just so that we can visualize it. It's not the right material, but at least we can see something. So with those two things, if I now run my application and we go here. Oh, come on, little cable. Is it starting? There we go. So now, oh, there, I thought I was missing a step. So, yep, it's not animating the hands. It's just positioning them. Let's see. So that's a sketch. So I think we just need to add one more node here, and that is our hand modifier node. And this one, again, to the same left or right. We're just going to do a full bone update. I'm going to do the same thing here. But now I'm going to put that on the right. So our node here handles our positioning of our hand mesh. But this node makes sure that our positioning of our fingers works. So hopefully I have got that right. And I have not missed a step here. So let's... oh, did I close that? That wasn't smart, was it? I closed my casting instead of changing which application we were in. So, bear with me a second that I restart that. There we go. Oh, and it's already running the application, or... no, it hadn't closed the application. No, hold on. Let me restart this. There we go. Unless I am missing something. All right, let's see if it wants to work now. There we go. Oh, and there we are. Yeah. Oh, this one is still wrong. We've missed something here because we can see our left hand is working correctly. I can move my fingers around and the hand is in the correct position, but I've made a mistake on my right hand. All right, let's have a look what we did wrong on our right hand. So, right hand modifier, that's all set. That is set to hand tracker right. Because this one is not set to the right hand. Okay. The easy, simple mistakes that we made. And I need to learn not to close this. Sorry about that, guys. I am just so used to closing windows instead of tabbing away from windows. Luckily, it is pretty quick in coming up. There we go. All righty. So now we can see that both hands are working. Now, obviously, in a pass-through way, I will not want my hand to be completely rendered, but we will leave that just now for visualization purposes, because we are quickly running through the time that we have today. So, and of course, I did it again. Let me just restart that so that it is running for the next time. And actually, let me also really quickly quit the application, because there's no point in running that on the headset when we are not doing something. Cool. I will get at the end of this workshop that I will remember to change applications and not close that one. All right, so that is our hand tracking. So the next thing that we want to do is we want to switch between pass-through and no pass-through. So for that, I am going to create a script on our main node so I can control that. Cool. And here I'm going to add a function called enable pass-through. And we're going to give that a Boolean so that we can turn it on or off with this function. Now, the other thing that I want to do, I also need to add a variable here so that I can track whether we actually have pass-through already enabled, and we're going to assume that it's disabled by default. The next thing that we're going to do is we're going to go to the start XR node, and now we're going to go to signals, and we see that there are a number of options here. When we have our focus gained, focus lowest, I'm actually missing one there. There is a slightly newer version of this where we also get a signal on session begun. So let's add that signal in. Because that's what we want to react on to. And now on our session begun, this is called when OpenXR is fully up and running and everything is set up. And here at the end, we now want to emit our session begun signal so that we can react on that. So I was expecting that to actually be part of this script, but I must have overlooked that one. And I do have my XR interface there. We will use that directly. So the reason why I'm doing that is I like to separate the logic that I make for my application from this start XR script so that I can reuse the same start XR script all over the place. And I can easily upgrade it to a newer version if a newer version becomes available. But yeah, we should have that session begun there because we only want to execute this logic one time on our session begun. So I just double click on that. And it will then ask us, do we want to create a method that gets called when that signal is emitted? Signals are a way in Godot to communicate things between different parts of the system without creating a hard link between them. So in this case, the start XR script doesn't care what happens when this signal is emitted. There can be one thing listening to it. There can be 100 things listening to it. It doesn't care. All it cares about is at this point in time, it's going to send out that signal. It's going to emit that signal. And whoever is subscribed to it can go and execute some logic. Now, by default, it assumes that it wants to do that on the main node. The main node here is selected, but you could link up the signal to functions in other nodes, but this is the correct thing for us. So we are going to connect that. And that now means that whenever startXR emits that session begun signal, it is now going to call this session begun function. And what we want to do at startup is we want to call enable. And I don't know why I called that enabled. I don't want a D in there. Enable pass-through, and we're going to set that to true. So we're going to make sure that when our application starts, our default is let's go and enable our pass-through. Cool. And with that saved, if we've done everything, well, we actually need to implement it. Almost forgot that. So here I can now say if pass-through enabled is enable, we're already in the right mode. We're just going to do nothing. Else we're going to say pass-through enable is enable, and now we're going to react to that. So if we should have our pass-through enabled, we're going to do one thing, and else we're going to do another thing. And the things that we need to do is, first of all, on our I'm going to make an onReady var for that. So onReady var, that is a var that is initialized at the start. And this is just a helper that we're going to create for start XR. And that allows us to get access to our XR interface. And that's a good one because that is not cast automatically. So let's go and just search for that. This is the only downside of accessing things in this way, is we don't always get the right helper things. Actually, yeah, we need to look at XR interface. So what we're going to do is we're going to set the environment blend mode. And actually what I want to do here is just create a helper. I'm actually going to add that here. So we're going to say XR interface, open XR interface is start XR interface. Normally I could also create an access function for this, but for now, that's fine. This allows us to now access it through this variable, and this variable is now auto-completed. So I can select environment blend mode is, and we're just going to set it to alpha. If we want to also support classes with this, we would need to do a little bit more checking, which see what is available and switch accordingly. To turn it off, we are going to go and change the mode to opaque. The other thing that we need to do, and again, we'll help create a helper variable for that. Viewports, and actually I want you gone, is get viewports. Yep. So the viewport is an entity, and we always have one default one. It is the thing that we render to. So it's a node that handles our interaction to the surface that we're rendering our 3D content to. So for that one, we need to say vp.transparent background is true. We have to make sure that our background, our render background, supports transparency. So we need to set that to true. And here we set that to false. Now the last thing that we want to do is we want to go and have a look at our environment mode, and we want to switch our mode from sky to custom color. And then when we have a custom color, we obviously want to set that custom color. So again, same thing here. We can get our environment. No, that needs to be an environment. And let's go and create a helper variable here for our world environment. There we go. So here we can say, let's go and copy our environment here. There we go. So the three things that we need to change, we get easy access to it. And here in this case, we want to say environment.mode. It's background mode is, so in this case, we want to have color. And for this one, we want to say environment background mode is sky. So we want to turn it back to the sky. And hopefully it remembers the sky. I think it does. And the second thing that we want to do is we want to change the background color here. And we want to call that to, we want to set that to color all the way black with no alpha. So this means that our default background color is completely transparent without any color in there. And anywhere where our background is transparent, we will see our real world. We'll see our camera data. So that should be everything over there. Let's go and test that and see if we now start up in pass-through mode. So, I first should start that and then go here. There we go. So in this case, when our application starts, so we hear a nice little sound for that. And now we can see that we are still in pass-through. I can still see my hands, but I now see my rendered hands on top, and you can see how nicely and closely that follows us. So cool. We have pass-through, we have hands. All right. the next thing that we want to do is we want to figure out things about our environment. All right. Now, the nice thing is, when we look at scene discovery, the core way that scene discovery works, we have followed through on with spatial entities. So while there are a couple of differences in how you set things up, the overall approach that I'm about to show will work the same whether we are in using scene discovery or whether we'll use spatial entities as that becomes available to the different systems. Now, we start again by searching for the correct node. And in this case, we are looking for our OpenXR FB Scene Manager. Now, I accidentally put that in the wrong place. That needs to be a child of the XR Origin 3D node. And this is a helper node that has been created that, first of all, enables the scene discovery system. But it also interacts with the scene discovery system, and it will continuously try and ask the scene discovery system, have you got new data for us? Now, with a quest, the nice thing about the scene discovery system in the quest is when you use this application for the first time, and again, I have already configured this all on my quest, so that part we won't see. But when you run an application like this for the first time, or you go into the settings to run the room setup application on the Quest, it allows you to scan your whole room, and it will figure out where all the walls are and where your desk is and where other objects are, etc., etc., etc. And it will capture that and it will store that. So this means that when your application starts, it has immediately got knowledge about the room that you are in. I do believe that nowadays they also support dynamic objects. So if it recognizes, say, a cup or things like that, there are ways to interact with that as well. But I've mostly been playing around with the room setup things. Spatial entities adds also the ability to do that live, so that as your application runs and you walk around, it will do that discovery as you go. But I don't believe that is in scene discovery just yet. As it detects things, as it knows where the table is, where the wall is, where the floor is, where other objects are, the scene manager is going to create Godot scenes or add Godot scenes as children to our manager node for each of the things that we have found. However, that scene is something that we have control over. So let's go and start building that. And we can see that we have the option to set up a default scene that will be used for everything. And we have the ability to set scenes for individual types of objects that it can recognize. So we're going to start with that default scene, and we need to create that scene for us. Now, the other thing that I really quickly want to do, because I am going to forget the name of this. So let's open that in our help. Yeah, that's correct. And set up, oh, because we have, yeah, perfect. We have, we can actually set what the method is called. That was the thing that I was looking for. So we go here to scene, we create a new scene. We call that a 3D scene, and we're going to call that a scene anchor. Oh, actually, yeah, anchor. Again, doesn't really matter what it's named, but we will call it that. And I am just going to save that in the root. I'm also going to go and give that a script. And I suddenly remember I actually want to change the type of this. I want to make this a static body. There we go. Because what I want to do here is I don't just want to know where my table and my wall and all the other things are. I also want those to become surfaces that I can interact with. So that is something that we want to do. Cool. So now that we have that scene, we will build the scene in a second. Have I saved it yet? Yeah, I saved it. I want to go and select that scene over here as my default scene. There we go. So this now means that for every object that our scene manager finds, it is going to create an instance of that scene and it's now going to call a function called setup scene. All right, so we need to make sure that that function exists. So let's create that function. Okay, and now I need to have a look at what is that called again. No, it's not that. So let's go and just look for scene. Scene capture extension, that's the extension. It's on the resource, I think. We have too many things called scene. This is the only thing. Wasn't it in the help here? No, it's not. All right. Sorry, guys. Bear with me for a second. I just need to remember that's the manager. That's in the node. Where are the resources? I think that's a resource type. Can I search on individual things? Yeah, I can. Okay. But that's again on the scene manager. All right, bear with me just a second because I just forgot what the name of this thing is. So when we go to the repository where we manage the vendor plugin, you will actually find a manual page here. And we can find all the information about everything here. So here is our meta scene manager. And it talks for all the things that we did. But the thing that I wanted to know was that one, spatial entity. That's what it's called. So entity, there we go. And that doesn't need to return anything. Cool. Now we have the right thing. Okay. So that's the one thing that we are still missing in Godot is the ability to define, okay, what are these methods? What are they looking like? What do they get? You have to find that in the documentation. If, like me, your memory sometimes doesn't help you. So every time that it finds a wall, a table, a desk, whatever, it will create a scene for us. It will call that setup function, and it will send us this object, an FB spatial entity. And the spatial entity object will contain a whole bunch of information and functions that we can use to deal with it. Now, the first thing that we want is this create collision shape function. So this is a helper function that will create a collision shape that matches the entity that we have just found. And in a lot of situations, that's all you want. You just want to create a collision surface because you can already see your desk. You don't need to render something to see your desk. You just want the desk there so that you can interact with it and you can drop something on it. But we're going to do a little bit more because we do want to visualize things so that we can see what is going on. But let's start with that collision shape. We have already changed the type of our scene to be a static body. That means that we automatically are a static body. We just need to add that collision shape to there, and we can do that in code. So we can create a var here, collision shape is entity.get. Oh, it was create collision shape. It was create collision shape. Create collision shape. There we go. So it creates that. And now we can simply add that as a child to our object. Sweet. So that should already make this interactable with our with anything that we create. Now we're running out of time, so I'm not sure if we're going to get that far. So I just want to get to a point that we at least can see everything and visualize everything. Now the second thing that we want to use is we want to visualize things, and we can do that with this create mesh instance. I'm actually surprised. I thought there was also a option for creating multiples. I don't know. So with the create mesh instance, works the same way as with the collision shape. It creates a mesh instance with a mesh that will have the shape of the object that we have detected. So let's go and add that in our scene actor. So we're going to do now mesh instance. So instance 3D. And we're going to say entity dot create collision shape. No, not collision shape. Create mesh instance. And we're also going to add that to our as a child to our node. So now we have the system create our scene anchor, adds it into our scene, and we have now created the collision shape and a mesh for it. However, I want to have a material with which I visualize that mesh. And just to make our life easy for that, we are actually going to create not a variable, actually. I want to create an export variable for that called material so that we can create that and set that on our scene here. And we can simply say on our mesh instance, we can do material override, and we can assign our material there. So that means that even though the mesh instance that we get from our spatial entity system might already have a material, I don't think it will. It'll probably just use a default material. We are now overriding that with our own material, and we need to create that. So let's create a new standard material for that. And we're going to go to our albedo, and we're going to select this cross grid texture, just so that we can visualize. That also means that I want alpha enabled. I actually want to keep the grid transparent, and we could give another color, but I'm happy for that to be white for now, just so that we can see it. So that will be the material that we use. Most of these meshes will be boxes or will be planes, so that should work. So if we've done everything correctly right now, all those things should be there. There's actually one more thing that I want to add in here. Let's go back here. And that is that I believe that there is a name in this as well. We can see what the type or name of this entity is. Get semantic labels. That's the one. Gets an area of semantic layer used by the spatial entity. All right, let's just see if we get this as a string of arrays. So dots get semantic labels. And for that, I just want to add a label 3D just so that we can visualize that. And let's just go and add each label in there. Come on. I think that should be enough. And then we can say, oh, that's, we don't really need an unready for that. We'll just do, oops, label 3D text is text. So this means that whatever semantic labels we get, we should be visualizing. So that should tell us whether it's a table, a wall, or anything like that. Cool. Sweet. Let's see if that works or whether we've made any mistakes. And of course, that means that I need to, there we go. All right. I am not seeing anything yet, so we have missed something. Because I was supposed to see all my things. Now, okay, with that running, let's go and have a look and see in our interface if this tells us anything. So is it telling us anything here? Open Explorer Manager, unable to query room layouts. So that sounds like a permission issue. Oh, and what's that? How's that? Okay. Why did it not ask for permission for scene? So, or has it asked that, but it hasn't given it? That's also possible. Where they changed this whole UI. I'm not used to this new UI yet. Where is my settings? Here we go, settings. And now, do I have, where are my permissions? Privacy and safety, maybe? Application permissions? Spatial data? Says that I have permission to that, so I don't know. Let's see if we've missed something in our setup here. Yeah, unable to query room layout. That usually means that we don't have the permission for this. So let's first have a look over here. Did we forget something over here? Maybe we lost something in a restart. Meta, pass-through, scene API. Is there anything else? Anchor API, anchor sharing. Don't think we need any of that. Okay, and then in here, is it one of these that we missed? Way down. Do we have something here? We got hand tracking, overlay, experimental. I don't think it's an experimental feature. Okay, let's go and have a look in here whether there's anything here that it says that we forgot. So we've got our scene API. We have enabled that. We've added our manager node. I think we've got that all set up, right? Close main. Yeah, we got all those. Does it say anything in the settings? Requests. Maybe because we are doing this too early. No, that should be part of. Scene manager is that. So that's just connecting the signal. So that's the same thing as we can just find those signals over here. So we can get signals on those and we can get an information about whether data is missing. Let's add that one in just to do a print and say there is no scene data. Let's see if that goes into our log. All right. Sorry, guys. I am a little stunned by this. That should work. All right, loading up. All right, we have our hands. And now in here, there is no scene data. Okay. But is that because we don't have... All right, well, one thing that we can try, seeing that it says here, we can therefore trigger our scene capture. And I'm just going to do, oh yeah, we're actually going to go and make that an onReady var. onReady var is OpenXR scene manager. And we want to make sure that we cast that so that we can use our auto completion. Okay. And then the other thing that it does here is on capture complete. Well, let's just copy that and do that same thing there. Actually, let's first get that in here. Just in case that does something. I thought this was always automatically done, but Maybe I have missed that. Okay. Oh, haha, it gets the wrong indentation. So let me just fix that up. Oops. All right, Inigo, I hope you don't mind if we run a little bit over time with this, because I wasn't expecting to run into this as a problem. All right. Why does it not go in here? I think we hit a breakpoint. We did. Request scene capture on a null value. Okay, that's interesting. Does this run before we're ready? Do I need to? It's always running that here. Oh, because here it doesn't connect until we're ready. Okay. Well, we can do a if return, and then obviously if not scene manager, we return. So in our case, because we've linked this up directly on the signals, this is active right from the start. So it's active before our scene manager node is actually known. So let's go and do that. Oh, that's the wrong one. There we go. All right. So let's see if that works better. All right, so now we get in here, but it's still not starting up. So I think we're really running into a permission problem, but I don't know why it's running into a permission problem. All right. Well, we have one more thing that we can try, just in case it is really just confused. And that is that we can go. Where did they hide that now? That's a good question. Library, yeah. Okay, where is our application? Where is our AR demo? That's just a Godot game. Unknown sources. There we go. AR demo. So we're just going to remove our AR demo. Cool. And now we're just going to rerun it. Oh, sorry, you guys didn't see that. I just went into the menu and I removed the AR demo. So it's going to run through its startup again. And it should ask us for permission again. There we go. Allow. No, that's just there. And then we are still. Oh, there you could see the switch between hand tracking and controller tracking. But it is still not giving me permission to run. I am not sure what's going on right now. Unable to query room layout. I am stumped because I tried this morning and it worked. All right, well, guys, I am going to have to go and open up the test project that I did this morning, or that I used this morning. And just see if I can see the difference between what we're doing and what they are doing. Yeah, the joys of troubleshooting. Unfortunately, not expecting that in the middle of a workshop. especially since I tried this one out. So this is that sample project that is being described in the help pages. Okay, so what are we doing different here? So this is on stage, but that doesn't matter. All right, so here we have, so this also does the anchor API. It has the environment depth API. I'm wondering if there is a extra permission that is being accidentally used here. So I might turn those on just to see if that makes a difference. But other than that, I don't see anything. Let's go and have a look at here. I just want to see if there's anything here that's different. I'm wondering if I should change that. Maybe it's getting confused with that. Boundary mode, we don't care about that. We're not using experimental. So seems to be all the same. So the only thing that I can think of is that it does require us to have, why is that? Oh, it disconnected for a reason, for some reason. Maybe by accident we have created a dependency between those other APIs. So we're going to add the anchor API in, and we're going to use the environment def API. I think only the anchor API is probably important. But let's do those two, and maybe that will trigger getting additional permissions that we need. Let's go over here, and let's see if we finally have success. Oh, I'm so used to just grabbing my controllers. Yay! Okay, well, that is a whole lot that it suddenly gets. And we are not getting proper transparency on the walls. Oh, that is because it's also doing, okay, that explains. All right, I'm going to talk about that in a minute, and we're going to change the configuration ever so slightly. So what we're going to do is we're going to remove this on our default scene. Clear. And we're going to actually select just a few of these. So for our ceiling, we can do our scene anchor. Oops, I clicked a bit too much there. Scene anchor screen. Let's go and do an invisible wall. That's fine. And we're going to do a window frame. That's fine. Let's do table. That's fine. So the reason why we suddenly had this whole view is because of this global mesh also being used. So let's do a screen. Don't really care about any of those. I'll leave those alone. So I think with this, or that's also to the floor. I think with all these, we have enough. So because the global mesh actually creates a really big mesh, and we might, well, we actually ran out of time, so I can't really show the global mesh off. But the global mesh is actually one big mesh of the whole room that you're in as a big triangular shape. But of course, because we have a shader that is actually shading every face of that, it just overloaded the whole thing. So let's see if with that we're good. Did I once again? No, where are you? Where's my? Okay, stop. Start. I couldn't see my window anywhere. Come on. Get back in there. There we go. All right. So. Oh, maybe we should have used the depth API. Why is it not moving with me? Oh, that's just so we can see our table shape over here. I was actually expecting a monitor shape here. Now, obviously, because I'm not doing any of my depth stuff, I'm seeing my wall over there. I'm seeing my ceiling, and it's actually drawing through everything else. But we can now see that all these things that I have, all these, so that's the floor that we can see. We can see that all these shapes have been created in our environment. So I think if we, yeah, okay. So, and because they're all transparent, we are, we are just seeing everything through the floor. But the important thing is we have all that information now in our application. Now, I'm very sorry that it took this long to get where we are right now, because the next step that I really wanted to show was that now that we have all those shapes, and obviously we would end up hiding or at least limiting how much we can see of those. But now that we have collision shapes for all those, what I wanted to show was that you could actually place things on there. But unfortunately, this took a lot more time than I thought it would. So I am very sorry about that. Let me see. Yeah, Inigo, thanks for that. So yeah, I don't mind going a little bit over. I don't know how everybody is in the classroom, whether you guys need to leave right away, but I am happy to take a few answers or a few questions before we call it a day. So Inigo, I don't know if there's anything that you want to share with me that we can talk about. And again, I'm very sorry. I thought that we would do this in less time. This took more time than I was expecting, but I still hope that this gave a decent introduction in everything that we have here. Obviously, there is lots and lots and lots more to cover here, and I might actually continue and do some more videos on this topic because I do think a lot of people want to play around with this. Let me have a read through your reply here. Yeah, cool. With spatial entities, we can then access the scene discovery API objects, low-level data, bounding boxes, etc. I'm just guessing, but probably most of our future work will focus on being able to detect objects and bounding boxes, perform some kind of process, and show complementary information in AR. Yes. So as you can see, when we finally had everything up and running, it detects a whole bunch of objects. And there is more information about those objects that is being shared that you can interact with. They are currently working on, and I don't know how much of that is available yet. Then instead of having the static environment of your room, that it can actually detect, like I said, a glass that you're holding, or a cup, or other entities that are around. I know that is in the pipeline. That isn't there yet today. But it means that, as you can detect those real world objects, you can therefore do something with that and react to that. But it will all work in the way that I'm showing here, where the OpenXR system detects the object, tells us about the object. We now tell the developer, hey, we have detected this object, go and create a scene, or which scene do you want me to instance, and then you can add your logic in that scene where you determine what you want to do with that entity. I'm also guessing that probably much of our future work will also focus on placing virtual content on top of real objects and some kind of label information that maintain alignment as a user moves in the real space. How should be approach anchoring so that the virtual objects stay aligned on top of the real ones while the player moves? Now, first of all, for the most part, when the player moves, things stay pretty much where they are. However, if you want to be in a situation where you want the system to track a physical location and make sure that a virtual object stays there, and that it is also retrieved when you restart your application, so that let's say that, and I've actually got a demo for that, where I put a plushie, a Godot plushie on the table, and I'm able to position it, and then when you come back to the application, it will be in that same location, and that is part of the anchor system. So, and again, that's both available through Meta's own APIs and through spatial entities. So in spatial entities, you can see that there is this spatial anchor system. In Meta, they have the anchor API. That was the one that we enabled. That I think there is a dependency between scene discovery and the anchor API, which is probably why we ran into problems. But the anchor API allows you to track that. Now, the nice thing about it, and I'll quickly show that, but we can't really go into that too deeply. But there is an OpenXR FB spatial anchor manager, and this allows you to both detect anchors that have been previously saved and recreate them. You can see that again, it will instance the scene that you define in which you define your virtual object, but also there's an API on this to add new objects in the scene. You give it the location and it will track that. This is even possible that in that scenario that I talked about earlier, where you have multiple people with a Quest headset in the same room, you can have one person place a virtual object in that scene, create that anchor so that it is in place, and then share that anchor with all the other people in the room so that they also see that same object in that location. So it's a really, really powerful system. And 3, can faces be discovered by the Meta API? So when you are looking at faces of people, I am not currently aware of an OpenXR API that does any sort of facial recognition or anything like that. I do not know if something like that is in the pipeline. So I honestly don't know about that one. I do know that that is obviously something that a lot of people are worried about privacy about. So cool. I'm going to quickly have a look at what has been asked in chat to see if there's anything that I can quickly answer there. So Francisco asked, what types of augmented reality glasses would you recommend for 100% use with Godot? So at this point in time, there aren't many glasses that have been released that have OpenXR support. So I can't fully answer that question yet. I know that there are a couple in the works that should be coming out this year or else early next year that will have full OpenXR support and therefore work really well with Godot. But right now, as far as I am aware, the only glasses format that works with Godot is the Magic Leap, and obviously the Magic, or actually the Magic Leap 2, and that one currently is not actively developed anymore. So I don't know of any of the others, whether they have OpenXR support, but for us, OpenXR support is the key thing. But obviously with Android XR now being a thing, Android XR has got a number of glasses formats on the horizon. And, you know, our expectation is that those will work really well with Godot. Obviously Meta's sold the world that they are working on glasses. We don't know when they are coming out or what they look like, but everything that we've so far heard is that they are basing it all on the same software stack as the Quest is built upon. So in theory, I'm going to assume that that is all going to work. When making a VR game in VR, is it hard to get the game compatible for all headsets, or does it require specific tuning for each headset? So that one I kind of more focused on yesterday. As long as you stay away from features that are specific to one headset, Godot makes it really easy to move between systems. The moment that you use something that is only supported on one specific headset, especially if you use one of the vendor extensions, it depends on how much work you do. Godot is built in a way that if a feature is not available, we simply don't use it, and the rest should still work. But obviously, if you are depending on that feature, your game may break. So there's that. The other thing that is really important for when you have a finished game, and this actually also applies to AR applications that you might want to build. If you actually want to place your application on the store, so on the Meta Store or on the Play Store or on the Pico Store, you generally have to deal with the store APIs of those systems, which requires using one of the proprietary plugins that accesses those. And again, you will be responsible yourself as a developer to make sure that the right little bit of store code is used for the platform that you're currently running on. It's all possible, but it's a little bit extra work that you need to do. But as far as the core is concerned, there is a lot that we have done to try and make games as cross-platform as possible. So a lot of stuff in Godot is really written in a way to try and emphasize on that. But it really is up to you to make sure that you don't use things or use the things that are platform dependent in a way that they become optional for your game. Cool. Thank you, Sebastian. I'm currently building a multiplayer XR demo for Proton Fusion Godot so that people could quickly bootstrap their multiplayer XR apps. And maybe a stupid question. When you do make multiple instances in XR in 4.6, at least it is often not possible to switch from one instance to the other. Yeah. I'm not sure. Do you mean like running multiple instances on the PC or somewhere on the device? Personally, I don't think it's possible. OpenXR is not multi-instance friendly. So generally speaking, when you start another OpenXR application, the one that's currently running gets shut down, and it might still be running as far as a desktop application, but it loses its connection with the OpenXR ecosystem. So when you want to do something like a multiplayer environment, the only way really to do that is to have multiple devices running. It's unfortunately a weakness of the OpenXR system. So yeah. Yeah. So I don't think your situation is super working, unfortunately. So yeah, you can run multiple instances of Godot, but only one can actually be an OpenXR application. So you could do a situation where you have one copy of your Godot game running as a desktop game, and then the other running as a XR game, and those can work together in a multiplayer environment. But you can't run two applications both as OpenXR application at the same time. So at least I'm not aware of that being a possibility right now, because one will just take over from the other. And if you use like Steam or something like that, Steam will say, "Oh, now this application is running," and it forgets about the other one. It disconnects from the other one, and it's gone. Okie do. I don't know if everybody at the university is still watching or if the class is finished. I hope everybody has enjoyed this. I'm sorry that we went over time. I thought that we would get through this quicker than I did, but I hope that it was still very interesting, that it at least provides a good basis of what is available and what we can do. Like I said yesterday, please don't hesitate to send me questions. I don't mind answering questions later on. So yeah, I hope everybody picked up something out of this, and that it was interesting. So thank you everybody for watching, and we will continue these things at a later date. So thanks everybody. I'm going to call it there. We are 10 minutes over time. So thanks for watching. And again, everybody at the University of Basque, I hope you enjoyed it. I hope it was useful. And I wish you guys a lot of success with working with XR things in your studies. So I'm going to leave it there. Thank you, everybody. See you next time.